7/4. And I'm going to solve that. Right off the bat, I'm thinking that doesn't look like a lot of fun. But what could I do to alleviate the fraction problem? Multiply by what? Multiply by their least common denominator, or multiply, multiply them by a common factor. In this case, what would be a common denominator of 3 and a 4? 12. You're okay with that? So the least common denominator is 12? So here's what happens. I know that I can multiply everything here by 12 because that's the common denominator. I'm going to do this the long form first to show you guys a couple of times what is occurring as you're doing this. As you're distributing out the 12 to each term, you get 12x over 3 plus 12x over 4 equals 12 times 7 divided by 4. Does everybody agree with me on that?
Yeah.
All I have done there was distribute the 12 to each individual term. Now, what's 12 over 3?
4x.
Oh.
What we have done now is gotten rid of the fractions by multiplying out by the least common denominator. Numerically. Yeah.
Have you ever done it where you like instead of multiplying just the numerator by 12, you would have done the common denominator, so you would have gotten 4x over 12 plus 3x over 12. So that way you have common denominator.
In essence, that's what we are doing. This is a little bit cleaner. This is a shorter way of doing this. Okay? Now, what's 4 plus 3? What's 21 divided by 7? Again, what we're doing here is we're getting that common denominator of the 4 and the 3 and going through it. Let me show you another version numerically before we get into more of the algebra with a little bit more of the variable stuff. What do you need? Okay. The idea here is to be able to identify your common denominator. Same things are holding true like we did yesterday, getting those common denominators. But now, what's a little bit different, we can get rid of the denominator because of that symbol. Because I can multiply both sides by something to get rid of a fraction. Take a look at this one. I have x over 3 minus x plus 2 over 5 equals 2. If I want to get rid of those fractions, what's going to be my common denominator of a 3 and a 5? 15. Does everybody agree on that? Okay. So if I multiply everything by 15, what's 15 divided by 3? 5. So it becomes 5x. What's 15 divided by 5? 3 times the x plus 2. And then obviously 15 times 2. Again, I think this is kind of where you were going, by multiplying by what they're missing. But by putting that number out in front, you won't forget to multiply the equal side.
But like in like a regular equation, or not even third grade math where you have to figure out, isn't that what we would do anyways? Like we would have to do it for all of them?
Yeah, you would, but a lot of times people forget. You'll get rid of the stuff on the left, but you forget to do that side. By putting it out front and throwing the parentheses around everything, it hopefully will remind you to send it to everything. That's usually where people mess up. So, like I've told you guys many times, I know where the mistakes usually are made, so I try to come up with ways to remind you guys by throwing those grouping symbols in. Try it sometimes helps. But if you're confident the other way, okay. So now, what do I do? Solve. 5x minus 3x minus 6 is 30. What's x? Again, The process here to be able to solve these is going to be the same for numerical as it will become when we have variable. The algebraic parts here, when we have to factor and whatnot, the process to multiply out is going to be identical. Let me show you a very simplistic start. Sir.
Wait, why isn't it 15x plus 30? Like, when you distribute?
When I distribute out here, what I'm doing is, move this down here. I had 15x over 3 minus 15 times the quantity of x plus 2 over 5 equals 15 times 30, or excuse me, times 2. What I did here is I didn't write that step, I simplified it within that step. Yes, sir? All right. So what's going to happen as we go further into this, we don't always necessarily have to throw this step in, because sometimes it'll be a little bit quicker. But if you want to throw it in, I'm going to do that with the when we start seeing variables a few times, but I might start to wean ourselves off of it here in a minute. Okay. Let's look at one with a variable. Three x plus x over 3 is 5. If I want to get rid of that over 3, because it's the common denominator among everything, what am I going to multiply everything by? 3. I'm going to multiply everything here by 3. Oops. By 3. When I distribute that 3 to all those parts, I have 3 times 3, I get 9x. I have 3 times x divided by 3 gives me just x. 3 times 5 gives me 15. So far, so good? All right. 9x and x. And you get 3 over 2. Again, all I had to do was identify what was going to wind up being my common denominator. In this instance, again, it's just a singular number. It's 3, which means everything in that equation can get multiplied by that, and the fractions go away. The fractions will go away. Because remember, when you're dealing with properties of equations, if you multiply it to one side, as long as you multiply it to the other, it's still happy. And happy equations are happy math people. Just making stuff up. Now let's get funky. One thing that this book tends to do, and I don't know why, a lot of times they're negative symbols they put directly in front of a fraction bar. I like to always put it in front of the numerator. So in this case here, it says that it equals negative 11 over x. Sometimes I think it's a little bit easier if you write it as negative 11 divided by x. That way you don't forget there's a negative there. I don't know why it does that. I think it just happened because of the typesetting. But just so you guys are aware of it. All right. So we have 4 over x plus 5 over 2 is negative 11 over x. If I'm looking at those 3 different denominators there, is there anything that I can factor? Do they all 3 have anything in common? Do 2 of them have something in common? Okay. What's that thing they have in common? What else is left? So what would be the common denominator? 2x. Remember, we're talking about factors here again. When we're getting common denominators, when we have to worry about our factor rules, remember, if I'm looking at a 1/6 and a 1/4, I've got 2 times 3, 2 times 2. What do they have in common? Well, this one they had 2's. But everything gets multiplied together. In this case here, the common denominator would be 2x. So what happens now is I can multiply everything by 2x. And I'm going to go step by step with the distributive property again to show you how these denominators drop out. When you distribute 2x times 4 over x plus 2x times 5 over 2 equals 2x times negative 11 over x. Each one of those singular terms now can be simplified. Everybody see that? In the first term, I have x over x. What happens? They drop out. So what's 2 times 4? 8. In the second group, what drops out? The 2's. Good. So what do I have? 5x. In the last one, what drops out? What are you left with? And there's your equation. Yes, sir?
Wait, so why the 2x again? That way we multiply.
Common denominator. In order to figure out what the common denominator is, you look at the denominators. Do they have anything in common? No. 2 of them have an x, 1 of them doesn't. One of them has a 2. To make sure that they all have something in common, you just multiply it out, those parts together. Okay? And now that's a 2-step equation we could probably do in our heads. Subtract 8. And x is negative 6. Again, the idea here is to eliminate the fraction. You guys hate fractions. This should be the greatest day of your lives because I'm re-showing you how to get rid of them.
Fractions are friends.
I agree. Not better than food, you're right. Oh, I thought you said fractions are better than, or not better than food. And I said, no, I agree. Yeah. All right. Okay?
It's obvious that this is the best.
Let's go again. Each one of these is going to get a little progressively weirder. So I have 5x over x minus 2 is 7. I would probably put that 7 over 1 when I'm writing the problems down, just so I know that there's a denominator there. Plus 10 over x minus 2. Again, when I'm looking at those 3 different terms, how can I create a common denominator between them? What would it be? X minus 2. So if x minus 2 is going to be my common denominator, I'm going to multiply everything by x minus 2. I'm going to show you the long form once again. I'm going to distribute to all 3 parts. X minus 2 times 5x over x minus 2 is 7 times x minus 2 over 1 plus 10 times x minus 2 over x minus 2. When you distribute that out, are you identifying that things are going to drop out? Using the common denominator within fractional equations is a lifeline for getting rid of fractions. Goes away. Goes away. You wind up with 5x is 7x minus 14 plus 10. What? I just wrote it all out. But that's fine. I'm going to stop writing it all out here very soon because I run out of
I believe that It can't be two.
Once you get rid of,
It can't be two, because there's no. I checked it, there's no zeros in the number.
I know,
It's just a trick question.
it is a trick question.
Viral.
Because what happens if it's 2?
And then you get zeros.
What happens? You divide by 0, right? Can you do that?
Yes.
No solution.
Just the big thing.
It will occur.
How often?
So
You do all that work,
Now we gotta go back and check them in there.
For there to be no answer.
but you're gonna be able to tell those zeros real fast. It's gonna be pretty straightforward, because even when we get to the trinomials that you have to factor, you're gonna have x minus 3, x plus 4. If you get those zeros that make it a 0, you know it's not gonna work. Okay. So it's one of those quick things. And you're right. The ones that we did this before, you didn't have to worry about. I'm glad you guys caught that. I was hoping you would catch it. Good.
How do you know? Like,
If x is 2, what's 2 minus 2? Can I divide by 0? Can I divide by 0? Bad things, man. So it's no solution. What movie is that from? Bad things, man. Bad things. It's a
Any
movie.
70 Matt?
No, it's a movie. No.
It sounds strange. Google it.
We will Google that later. Google is awesome. Let's take it up a step. What do you got?
So, I saw it and I wanted to start it off by what was
You can't. If it was fraction, it would fraction multiply, but since it's fraction plus something, you don't want to move those fractions. Because then you could have moved that, you could have subtracted that one fraction to the other side, and then you could have used that denominator as a fraction. That worked. A lot of times you just have to go down. All right. Now, when I'm looking at this one, I can't go straight forward to get my common denominator because one of the denominators needs to be factored. So, x squared minus 1, how can I factor that? X plus 1, x minus 1. What I'm going to do here is just kind of write that below here. So now, between those 3 different parts of this equation, what will become our common denominator? X minus 1 and x plus 1.
I have to do both.
Yeah, use both of them. All right. They have the x plus 1, but it's missing the x minus 1. So your common denominator here becomes x minus 1, x plus 1. My suggestion now is to not write out the distributive property for everything, because it gets a little bit messier when you have these multiple terms for your common denominators. And I know some of you guys are already doing that. What I'm going to do is, in this first problem, what's the only part that needs to be multiplied in?
X minus 1.
The x minus 1. Do I need to worry about anything from the denominator? Because it would simplify itself out. Does everybody agree on that? So I get 4x plus 1 times x minus 1 equals. Do I need to distribute anything to the 12th? I don't. The reason is because it already has both of them. And what does the 3 need?
3x plus 1 x minus
It needs them both. Okay. In order to now solve this for x, we have to do some foiling and some combining of like terms. If I FOIL the left side, I get 4x squared minus 4x plus x minus 1. Yeah. with the x plus 1. But yes, that's that whole term.
Oh, okay.
So that winds up with 4x squared minus 3x minus 1 equals 12 plus, what was x minus 1, x plus 1 if you FOIL that out? It was x squared minus 1, right? So can I just write this as 3x squared minus 3? I already know what it is multiplied out, because I factored it earlier. X plus 1, x minus 1 is x squared minus 1. All right? So now it's just a matter of you got variables on both sides. You want to set one side equal to 0. What direction are you going to move? You're going to move everything to the left. Because you want to pick on the little guy to set, you want that x squared term to be positive. So I'm going to subtract the 3x squared. And here I just have, what, a plus 9? So I have to subtract 9. X squared minus 3x minus 10 is 0. What's that? 12 minus 3? What times what's negative 10? You add together to get negative 3. 5 and 2? You have 2 possible zeros here. 5 and negative 2, which means you just have to double check. 5 or negative 2, they will both work in the denominator. Again, this right side here wound up being 3x squared plus 9. I moved it all to the other side to set it equal to 0. When you get to the equation parts of these things, when you have multiple terms as far as having a factor going back and forth, it can get a little bit long. All right, it can get a little bit longer to go through. But hopefully it's not so scary. It's all about factoring, 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 factoring.
Are you going to multiply by x plus minus 1?
Did either of those solutions work?
You didn't get any zeros, I think they both worked out. Yeah. Okay. So I have 2 over x squared minus x equals 1 over x minus 1. There's a couple of different things we can do. First thing I can do is I can factor my denominator on the left. What's the GCF? X. So if I factor out the x on this side, I have x times x minus 1. What would then be my common denominator? X and times x minus 1. So if I multiply both sides by x, x minus 1, does the fraction on the left mean anything?
Why are you multiplying it with that extra x?
That's the common denominator. No, if you need to get a drink, go right ahead. That's not a problem. What happens here again, they already share the x minus 1 in common. What else is left?
Oh, right.
At x.
X equals 2. I got you.
And then what is the other side missing?
They all be like,
What was the other way you could go about this problem? Yes, sir. You can cross multiply on this one. And why is this a type of problem you can cross multiply? Because there's no addition in there, right? It's actually fraction equal fraction. If it ever is fraction equal fraction, you want to go back to cross multiplying, that's fine. Because it'll work. You'll get the same setup. But yeah, by using the common denominator here, it just was x equals 2. Sometimes that can be somewhat okay. All right. That's this one. Do that one. If it's fraction equal fraction, you can do that. There was an algebra, an old algebra around somewhere, and I left it on the desk. Does anybody see that old algebra book? Oh, there it is. Thank you. This was an algebra 1 book. You should see the problems in this. You guys hate it.
Is it like
Good. Very visual.
Why would you hate that algebra 1?
It's there's some pretty awesome old stuff that older style problems that you guys had to do with this.
The library is like we selling all the old books, and there's like 1930s algebra book, and it's like this big.
And the math in it was unbelievable. All right. What did you guys do for a common denominator here? X plus 3, x minus 3. Does everybody agree on that? Okay. I'm sure some of you guys might have cross multiplied. If you cross multiplied, I'll double check your work here in a second. If I multiply everything by x plus 3, x minus 3, I know that the first fraction just needs the x plus 3. The other one doesn't need anything. So I get, what's this, 5x plus 15 is 2x. So you get, what's that, negative 3? No, negative 5, thank you. You get negative 5. What's that? Yeah, using the brain the wrong way. Yeah. Now if you cross multiplied that, you would have gotten 5x squared minus 45 is 2x squared minus 6x. So you get 3x squared plus 6x minus 45 is 0. A whole lot of uglies, right? When you have to factor stuff out and go that way. I mean, it works.
when do you know you can cross?
There's just
And you're going to get,
15 and 15 is negative, or 15 and
and you have to throw out the 3 there because it doesn't work as the 0, but the 5 does. The negative 5 does. You get the same answer, but you have to identify that if you use the 0 for 3, it won't work. That's all. But either way, it will work out. So what I want you guys to try out tonight is I'm going to give you a handful of these to go through. On Monday, my idea is to take 15 minutes, review this stuff, and then bump up the review times as far as the finals are concerned. So that being said, I'm going to give you guys a 5-question quizam Monday. We have 3 sections. There's 5 questions out of the 3 questions. I don't know, a billion.
Sweet.
Okay. So let's see, this is 9-6. Let me open this up.
You get 100 here.
I would like to do.
give me the one.
Oh, here. I forgot to write down the problems last night.
What is yours? Okay, for us, we have classes.
Let's do this. 9-6, it's page 571. Let's do that. Okay? Let's do 4 of them.
So then you know what plays on Monday and then.
Yeah, well, we're not going to do the test. It's not going to be a test. We're just going to call it the quiz thing and call it a day. That way I'll give you guys 3 days of review. Yeah. 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 So, again, what'll happen here is on Monday, the first 15 minutes, we'll check those. Any other lingering questions? And that leaves you guys, what, 30 minutes to do 5 problems?
Oh boy, they're gonna be hard. Yeah, I don't know if I can do that.
And it's only 9-4, 9-5, and 9-6. Just on those 3 sections, okay? The other part of today is that I'm going to get you guys a copy of